All right, everybody. I've got 10 o'clock, so I'm going to go ahead and get started here. Thank you all for joining me for Generative Design is for Inventor users too. Just to kind of give you a little bit of an idea of the inspiration behind this class, because all my classes have some sort of inspiration. As I've been working a lot with generative design in Fusion, I'm like, man, this is a really good workflow. You know, it'd be really nice if Inventor had something like this too. And then it dawned on me, I'm like, I don't have to wait for Inventor to have this. I already have it here in Fusion, and Fusion and Inventor work very nicely together. I don't have to wait for a tool like this to be developed in Inventor. You know, all of our Inventor users out there could start really taking advantage of this right now. They just need to know how to connect the two dots between Inventor and Fusion. So that's where I'm kind of coming at with this class today, to kind of show you what it takes to do generative design, how to connect Inventor to Fusion so you can do that, and hopefully you guys will be able to find ways to leverage this workflow, because honestly, one of the themes that Autodesk is always pushing through their media and their and all the things that they push out is the future of work. And I definitely believe that one of the things that we're going to see here in the future is where we're going to do a lot more collaboration with AI and things like that, that we'll be able to, we kind of feed it some information and the software gives us maybe the best configuration or multiple configurations. So probably the best thing for me to do is kind of just give you an overview of what generative design is, what it's kind of meant to do, and then go through a demonstration. So that's kind of like my process here. Real quickly, I'll start with some introductions. So some of you may have met me before. I recognize a lot of the names in the attendee list, but for those of you that don't know me, I'm Steve Olson. My role at Mesa is I am the manager of training services, which just means I oversee our training business, or that side of our work and our services. And I do some training myself. I have a couple of certifications from Autodesk. I am a Autodesk certified professional. I have a couple Fusion certifications that you can see there. I'm also an Inventor certified professional. I like to collect these things just because it's part of my role, certifications that I need to have, but I have a handful of them in a variety of different areas. There is a generative design certification. I haven't gotten to take that one yet. That's on my to-do list for 2021. But at Mesa, I do basically teaching, consulting, support work. I had my support day on Monday, and it was full of all kinds of interesting questions. I've been at Mesa for 12 years. Before that, I spent 5 years at a company called Fleetwood Folding Trailers, and there's a picture of what I worked on for 5 years using a variety of Inventor, AutoCAD, a little bit of Pro E, a little bit of Anvil, to kind of name a few products. And a little kind of funny note about this picture, that is me and my wife back in 2004 when we were in the product brochure. Back in those days, Fleetwood liked to put their employees in the brochure, and there was my wife and I, fairly newly married, like I said, back in 2004. So that's 16 years ago, when we were in the company brochure. So again, the agenda is to kind of give you an overview of generative design, and then I'm going to give you a demonstration on what that is. You have to create these things called preserves and obstacles. There's a couple of different ways of doing that. We'll also create loads and constraints like we're doing in FEA, and then we'll calculate some outcomes. That takes time. So I actually have a model I ran yesterday that we can kind of look at the outcomes there, and then we can take a look at what the output looks like. And if I have time, I can then take this and put this back in an Inventor model. So quickly here, I always like to get an idea of who I'm talking to, where you're coming from, what do you know about what I'm about to talk about, if you have no idea or a little bit of an idea. So I have a quick poll question, is have you seen the generative design workflow in Fusion 360? Let me launch this poll real quick. It's just a simple yes, no, or I've heard the term, but I don't know anything else about it. So I'll kind of give you a couple moments here to respond, and then I'll close the poll out and I'll share the results with you all. I'll just give you another 5 seconds here. Most of you have already voted, so another 5 seconds. Fantastic. I'll close the poll here and I'll share the results. So if some of you actually have seen the result or have seen this, a couple of you have not, but the vast majority have heard the term, but you're not very familiar with it. So this is exactly the sweet spot of what I'm looking to see. Some people that most of you have heard of it, but don't know a whole lot. Some of you haven't, and a few of you that are actually familiar with it. So let me kind of hide the results here. One more poll result, and this may not go too well since some of you haven't heard or know much about it. But if you have, knowing what you know, which some of you might not be very much about generative design, do you feel like this is something you could use as part of your design process? So let me launch this poll. So again, a little yes, no, not sure. So, knowing what you know of generative design, is it something you think you would like to be able to leverage? And since most of you aren't super familiar with it, you may not be able to answer this very well, but we'll just kind of go based off of trying to answer this. I'll give you another couple seconds here to try to answer this one, and then we'll dive into actually covering this material here. So most of you voted, so I'll go ahead and close the poll here and share the results. So most of you are a yes, and some of you are not sure, and that's fine. Hopefully by the end of today, I'll have you confident enough that you are in the yes column for that. But let me hide the results here and kind of get back to my PowerPoints. They kind of keep me on track. So one of the things I just going to talk about here real quick is just kind of the way that CAD has changed over the years. Very early phases, AutoCAD, purely documentation. Just kind of taking, it was just a glorified version of what 2D board drafting was, the old hand drawings. We moved into the Inventor realm where we had parametric 3D models and solids. We were able to put them together, get a little bit better of a feel for how things went together, and we were able to run some FEA analysis on that. And that was a little bit more reactive here. And now we're going to kind of get to a proactive phase if we can leverage this generative design, where we're going to be able to explore multiple different outcomes in our design process and hopefully turn out the best possible product that we can with this in mind. So one of the biggest challenges in traditional CAD is just, we kind of only have a limited amount of time to explore different alternatives. We kind of have to hurry up, pick one, and then kind of begin developing that. With generative design, we actually don't necessarily have to do that. So, here's our old traditional design workflow. So we kind of get a couple concepts, we pick the best one, we work on validating it, and then we start producing it. So we also have to do a little bit of validation in terms of manufacturability, evaluation, along the lines there. And now then we have our product. With generative design, we can kind of revamp that design process a little bit. So instead of being able to only validate or evaluate one or two possible designs, we can actually have the software validate many, many different possibilities. We can filter those out based off of manufacturability, cost, things like that, and then we can then begin producing it. So we should be able to shorten the design process and also turn out a better product because we've actually leveraged the software to evaluate multiple different possible variations for this product. So what is generative design? So it is going to be a design exploration where we're going to be able to, like I said earlier, we're going to kind of create things called preserves and obstacles, and I'll explain what those are when we get there. We're going to create constraints just like we would in an FEA analysis. One of the best things that I like about generative design is that it is manufacturing aware. I can say, I want to 3D mill this out of steel. I can also tell it what material I want to use. So I can kind of, and when I get into my study, I'll say, I want to try these couple different manufacturing methods. I want to try these couple materials and let the software figure out for me what are these different configurations. It's going to then give me multiple different options. I can then start filtering based off of mass, cost, which manufacturing method do I think is the most desirable or the easiest for me to get to. So I'll be able to kind of manufacture that way. Again, it is manufacturing aware. I can put in 2-axis laser cutting, machining, milling, that type of thing, 2.5-axis, 3-axis, 5-axis. I also can tell it that I want to additive manufacture this through 3D printing. Also has a casting option as well. And then one of the options that we have is that it's unrestricted. It just basically figures out the best possible shape, not worrying about anything. And all of these things are things I can turn off and on depending upon what my outcome needs to be. And then also one of the great things about this is that under old things like the shape generator, it was kind of it just was a mesh. You really didn't have a whole lot you could do with it. This is going to be an editable file. I can then go take a look at it. If I'm not happy with some of the ways it comes out, I can kind of correct that. If I did 2.5-axis, it's going to come out with more of a sketch and extrude type methodology. If I use something like 3-axis, 5-axis, additive, it's going to be more of this T-spline format, which is what's in that little animation right there. But that's going to be completely editable. And when I'm done editing this, I can then take that into the simulation environment. And because this was generated from a generative design file, all of the loads and constraints I put on it when I was creating the design study will be carried over into my output. So I won't have to reset that up. It actually will give me a message saying, hey, it looks like you did this from generative design. Do you want to use all the loads and constraints from that study? You say yes, and you can basically hit solve, and you can see if any of the edits you've made have then changed the ability or the capability of this part. So again, the manufacturing methodologies that we're capable of is additive, die casting, 3 and 5-axis milling, 2.5-axis milling, and then 2-axis cutting are the capabilities that we have. And then there is this unrestricted methodology that it basically just figures out the best possible shape and doesn't really worry about it. You might say, Steve, okay, well, we've had Shape Generator and Inventor for 4 or 5 years now. How is this any different or any better? So with the Shape Generator, that is really topology optimization. So it is similar in the fact of how we're going to set things up. But the difference here then is when we get that out, it is just basically a mesh file. We have one option. It's not manufacturing aware. It doesn't know how I want to manufacture it. So I've taught that example. I've taught that workflow in my classes in the past. And so what I tell people is, okay, you're going to get this mesh file that you can A, 3D print, or B, push back into your CAD file and then use as a way of lightweighting. And that's kind of what the thought process behind the topology optimization is, just kind of lightweighting. We have a little bit more of a few more options when we go into generative design. So kind of comparing the two, topology requires expert user to invest time in fully confining the problem, and generative design is more of an exploration method. Typically, it's a lightweighting goal. And generative design, we're looking for all viable outcomes that we can then consider. Again, topology gives us just one, and then typically it's not manufacturing aware, which that is one of that's to me that's one of my top 3 things that I like about generative design, is that it is manufacturing aware, and that's what we see here. So one thing they've added, and I promise I'll get to the demo here, just got a couple more things I want to talk about, is they've actually added with this a priori integration. That's where their costing engine is coming from. They've actually worked with this company to kind of bring their costing method into the generative design process. So kind of just give you a quick little glimpse into the capabilities here, some of why we would use this. So the object on the left is what a human would have designed. Very, 2D, sketch, extrude type methodology. The second one is the outcome from a 2.5 axis generative design study. The third one is from a 3 axis generative design study, and the last one is an additive. So if we look at those, comparing them to the original part here, the original human design had a safety factor of 2.7, cost $160. It weighed like about 3 kilograms. If we went to the 2.5 axis, you see that it's 2.3 kilograms, so it's almost a quarter lighter. The safety factor is a little bit less at 2.2, but it costs $30 less. The 3 axis generative, still about 2.3, so about a quarter lighter. The safety factor is actually 2.3, so still good, but not a little bit better than the 2 axis. And it costs $145, so a little bit more there. And then the additive is 2.5 kilo or 2.2, so it's over a quarter lighter. Safety factor is right at 2, but it costs $418 to manufacture. So these are all the things that we could then take a look at and consider. Is cost a factor? Is the safety factor important? Is the weight important? Which one of these is the most critical element for us in the design? So real companies are using this. This company, Wheel, used it to create the frame for their for these motorized wheelchairs. You can see that they were able to get a 30% weight reduction, which with these, people picking them up and loading in the vehicles and things like that, a 30% weight reduction for the chassis on that is fairly significant. The other one, and this is the one that Autodesk tells a lot about, is the rear seat belt bracket in almost every General Motors vehicle. I think it's in all of them. There might be a couple that it doesn't. So they basically had an assembly that was 8 components, and they were able to use generative design to create something that was 40% lighter, 20% stronger, and instead of being 8 parts that require someone to put it together, it's now 1 part that they 3D print. So these are the types of things that companies are doing out there. 3D printing doesn't have to be part of the workflow. I know whenever a lot of people, at least for me personally, when I looked at those, I was like, these all look like they're 3D printed. But if you dig into them, you can definitely do some of the 3-axis and 5-axis milling on them, depending upon what your capabilities are. So here's a little bit of a animation of how kind of the thought process goes. It starts looking at the paths of stresses, and if it can eliminate material in an area, it will. You can see the software kind of goes through multiple different configurations. It lets us then filter and sort through and find what we think is the best one. And then this bracket actually is the one that GM decided to go with. And there's a quick little animation of it being 3D printed for us. And like I said, it's from the rear seat of GM vehicles. You can see there is the original, and then the actual one's going to drop in here in just a second. All right. All right, so now let's get into the actual demonstration of it. So I'm going to start with the object on the left there, which is just basically a caster. This is kind of like my go-to example here. It's a fairly straightforward example of what this would look like. I've already got the design done in Inventor, so let me kind of jump over here. I'm going to open up this caster assembly. It's a very simple part, and look at that. That has the wrong bracket in it because I was trying this one out yesterday. I'll have to refresh the original part here. Just give me a moment here. One of the other tools that I'm using here, so while this happens, one thing to kind of mention is I'm going to have Inventor, I'm going to have Fusion, which are if you're buying the product design and manufacturing collection, that is what you probably are, what you already own. Let me replace this here. Component, replace with the actual frame. I have to fix that here in a second. So let me just put a quick join on here. All right, there we go. So real quickly, just the tools that are going to be involved in this. I've already got Inventor, I've got Fusion. What I was trying to say when I was too busy trying to fix the model there was the fact that if you're buying the product design and manufacturing collection, which is what most of our customers purchase, you have both those tools. One thing else that I have, and it's just a very minor piece to the puzzle, not mandatory by any way, any stretch of the imagination, but something that's going to make this process work a little bit easier is I have Fusion Team, which is another level of Fusion that it gets into some of the data management. It allows me to do some AnyCAD. It also allows me to set up a project on my C drive that automatically syncs to my Fusion team out in the cloud, which is where my Fusion designs are going to sit. So the Fusion is cloud-based. So I'm using Fusion Team and the desktop connector. So these files get pushed out to that storage automatically. That's the only thing that I'm doing that was the additional tool that I would have outside of just straight up product design, manufacturing, collection. I'm just doing that because it's going to make this process slightly smoother. But realistically, there's no reason why I can't take a file, upload it to Fusion manually, and then leverage that. This Fusion Team plus the desktop connector, which is free if you have the Fusion Team, it basically just does that for me. So that's about the only thing that I'm doing. All right, so let's get into what I've got going on here. So I'm going to use this caster here, and what you need to do when it comes to generative design, you have to, I'll bring a slide up here because I think it's going to be easier. So you have to decide or define what they call obstacles. So these are going to be things that my part has to avoid. In the case of this caster, that wheel is something that's going to be an obstacle. I can't have the frame go into where the wheel is going to be because it's going to create an issue. I also can create what they call preserves. Preserves are going to be areas that are going to be part of my final design. In my final design, I have to have that pin that goes up into the object that I'm connecting into or what the caster is going to fit into. Also have to have a spot for the axle of the caster to fit through. So those are things that are going to be my preserves. We're going to put loads and constraints on there. They're going to tell it how much load it's going to be faced with. The constraints are going to be how it's going to end up being held in place. Materials, we'll have to then define those, and also the manufacturing methods. So a preserved geometry, here's a little screenshot of what that's going to look like. The top object there is that pin. Those two cylinders there with holes are going to be where the axle goes through. In Fusion, they're going to be, once I've defined those as preserved, they're going to show as green. I can define these in Inventor or Fusion. I'm going to stay in Inventor because that's the tool that you're all familiar with, but I could just push this over to Fusion and do it there. The obstacle geometry, you can see I'm going to have an area around the pin that's going to be, the pin's going to be inserted into the wheel, the axle, and then also the nuts that go on the axle. There's a specialized connector type or obstacle tool that is designed for things like bolts, and it has the ability to kind of put the shaft, the head, and also a tool clearance that I can then assign and show that to. Again, can be defined in Inventor or Fusion. So let's get into the demonstration here. So I've got my assembly. What I would do is I'm going to start by starting a brand new single IPT, and I'm going to derive certain geometry from that Inventor file into this one here. So I'm going to use my derive command, and I'm going to pick up my axle assembly. So I didn't have to open that file. I just did that so you folks can see what I'm working with here. So I'm going to open up my axle or my caster. I definitely want the frame to be brought in. I want the wheel to be brought in so I can reference that as some geometry for my obstacle. The axle here is not going to be that necessary. For my derive style, I'm going to maintain each solid as a separate single body, because when I take this over to Fusion, it's going to be able to see these bodies. So I'm going to go ahead and say OK here. So I've got my top and I've got the wheel there. I'm going to actually split the top pin separate from this main part of the frame, because when I go to do these obstacles and preserves in Fusion, it's going to read by a body. And that's why I kind of split these into separate bodies. But I'm going to do a quick little offset plane here from this face, no distance, and then use the split command to tell it I want to split solids. I want to use this as my split tool. This is my solid. So I'm just basically segregating the pin at the top from the main frame there. I'll say OK. And so now I have my three bodies. And actually this, see which one here is it? This number 3, I'm going to actually even name it preserve 01 or 1. I just kind of do that. I just kind of like to name those preserves. The other ones don't necessarily need to have a name there. I'm going to create an extrusion for my other two preserves. So I'm going to create an extrusion. I'm going to sketch on the side face of this, project in this geometry, create a little circle here, and I'm going to extrude this to the inside wall. By the fact of what I'm doing here, it's going to try to do a cut, but I want to make this a solid. So now I have another solid 5 here. I can call this preserve 02. And then I want to mirror that to the other side. So I'm going to go to mirror. I'm going to mirror solids. I'm going to pick out my preserve 02. I'm going to pick a mirror plane here. This one here would be good, so it's going to mirror to the other side. I want this to be a separate solid from the other one, so I'll go ahead and say OK there. And now my solid 6 can become preserve 03. Two obstacles here I'm going to create, then we'll start passing it over to Fusion. I'm going to create a sketch on the top here. This is going to be that obstacle around the pin. So I'm going to extrude this. 1 inch should be fine. Make sure it's a new solid. We'll call this obstacle 01. And again, you don't have to name these. I'm just doing this because it makes my life easier. Some folks even like to color these red and green here before they go over to Fusion. I don't find that 100% necessary. So now I'm going to create another sketch so I can define the obstacle for the wheel. I'm going to find the right plane to sketch on. I'm going to project in the center axis, or the center hole, and the outside diameter there. I'm going to offset the outside diameter of the wheel because I need a little bit of clearance. I don't want the frame to come all the way up and touch the wheel. Obviously, it's going to create some friction and create some dragging. I don't want that to happen. I want a little bit of clearance here. I'm going to use a 1/16 of an inch for clearance on that. All right, so now I have that. So now I can finish this one more extrude before we pass over to Fusion. So I'm going to do, I also want to get rid of that profile in the middle there. So I have basically the shape there that I need. I'm going to go off of midplane and, oops, midplane, Steve. 1 inch off of midplane, which will fill our gap. If you look there, it's going to fill that gap. Say it's a new solid. This will be obstacle O2. All right, so this is all that I need to do here in Inventor. The obstacle for the axle, I'm going to use that specialized tool in Fusion. So I'm going to go ahead and save this. This is where I would then upload this to Fusion, but because I'm using the desktop connector, I don't necessarily need to do that. Oops, I need to save this first. So I'm going to call this caster, we'll call it Gen Design Caster, and I'll say live since it's the one I'm doing live for you. So we'll save this. I'll close it. Close this as well. So now I'm going to jump over to Fusion. I've got my Fusion team going. Like I said, this is where I could go and grab that file and upload it. But because I'm using the desktop connector, it should upload automatically for me. Let me check my desktop connector here. It's working on it now. It looks like it's done. I'll refresh. If you don't have Fusion Team and the desktop connector, it's just a matter of going upload. You'll grab your file, pull it into here, and then you can then place that right into your design. You can see I have that one here. I'm going to place it right into this, but I need to save this one first. So let me save this empty file here. So I've got basically with Fusion, if any of you aren't very familiar, every time you open Fusion, it kind of creates an empty file there. Before I drug my derived component into that file, I have to then save it first, just like Inventor would want with a reference here. So I'm going to now tell it to insert that derived Gen Design Caster Live into my current design. If I chose to define those preserves and obstacles in Fusion, I could do that here. I would place it, go through that similar process here in Fusion. I chose to do that in Inventor purely because I wanted to keep this as much Inventor-based for you as possible, because I know that's the tool that you're all familiar with. Fusion is a little bit newer to you, and I didn't want to kind of do too much here in Fusion. So I've got this. If I look at my design here, look at my bodies, you can see I've got all my preserves and everything there. So I'm going to jump into my generative design environment. So almost everything in Fusion, or at least in this environment, they want you to kind of work left to right. So here under study, I've already got a study started. I can look at the study settings. The resolution is just how coarse or fine I want to work with. This alternative outcomes, it's actually relatively new. It was added through an update yesterday. I read up on it. It basically has to do with some alternate versions or alternate solutions when you're dealing with 3D printing. I think it has to, from what I remember reading, it had to do with different build directions if I was going to 3D print this, either unrestricted or through the 3D printing methodology or the additive manufacturing technique. So I dealt with study under edit model. This is where I have a couple more options. I can remove features. I can add a couple things to define preserves or obstacles. The only thing I'm going to do here is use this connector obstacle. This is a really great tool for any kind of hardware, or in this case, this axle. So I'm basically going to say where the start of this should be, flip around, pick where the end of it should be. You can see I also have additional options for a bolt head, so I can enable that. It'll ask for the diameter and the height. I'll up the diameter of this just a little bit. I'll change the height down just a little bit as well. I want to change that down to 0.375. Right now, because it's considering a bolt, it only has it on one side. There is an additional option for both sides. So now I can have that head on both sides, almost like a head and a nut, if you think about it that way. There is an additional option for tool clearance. So you can see it'll add another option, another tool diameter and length there. So for me, this is almost like a socket or maybe a screwdriver that we need to make sure we have clearance to get down to tighten this object. In this case, with this caster, not a big deal. I've done some other examples like a bookshelf bracket, and that you kind of need to make sure you can be able to get a screwdriver or something in to screw the bracket to the wall and also to the shelf. So that's the scenario where that would come into play. This one, not that big of a deal. I'm going to say OK. I'm going to finish my edit model. You can see that that obstacle now becomes red because it's considered an obstacle. And over here in my browser tree, you can see I've got obstacle geometry and there's one body there. So I'm going to now come up here and say preserve geometry. I can pick it out of my window, or if I'm going to be picky, which I sometimes get a little bit OCD with stuff, I can pick it right out of my browser as well. So there's my 3 preserves. See 3 bodies, say OK. They all turn green. I'll go to my obstacle geometry, pick up, and actually I just realized I did that wrong. I have a tendency to do that. Let me do my obstacle geometry again. It should be the pin. I made that mistake with I screwed up my preserves. So that's my preserves there. And then the obstacle will be this object here, and also this object here. So if I say OK, now I've got 3 obstacle bodies and I've got 3 preserve bodies. If I want to turn off certain things, I can do that. Some of those are tied. Those preserves are tied, so I can't necessarily turn everything off. But if I want to turn off that solid there to kind of get a little bit more of an appropriate appearance, I can see that. All right, so now, kind of again, working left to right here, I've got my preserves and obstacles. There is a third type of object you can define, and that is a starting shape. So if I want to kind of say, okay, here's the shape I want to start with, I can define that. That turns up as yellow. Not necessary. It's not required, so I don't always do it. There's been 1 or 2 examples where I'm like, oh yeah, let's go ahead and do that. There is also a symmetry plane that I can enable if I want this thing to be symmetric. I'm not going to enable it in this case, but I could say I want it to be symmetric around a specific plane. So let me kind of get in here. So I've gotten through that. So now I'm going to do my structural constraints. So I'm going to turn off my obstacle geometry because these need to be tied to your preserved geometry. The new update yesterday allows for remote constraint and load options, but these are going to be right on my preserve. So I'm going to just turn off my obstacles. I'm going to fix the center hole in where the axle goes, and I can define those as basically blocking down all 3 axes. And let me turn off my obstacle geometry again. So that is my constraint. If I look underneath my load case, if it'll let me expand it out here. There we go. Under my load case, I've got loads, I've got constraints. Notice that one of my loads is gravity. I can enable or disable that. If I hit my little edit here, I can see which direction gravity is pulling, and I can change that if necessary. But I have this set up that gravity is in the right direction, and I'll use it in this case, so no changes needed there. I'm going to put on here a structural load. So I'm going to put on a force. I'm going to put it on this face right here. I'm going to say it's going to be 100 pounds. So we're going to apply that face there with 100 pounds. I'll say OK. I have a total of 5 load cases that I can quickly create here. And one of the ways I can do that is by cloning that initial load case. So if I go back to that load case 1, I can tell it to clone it. And what that does is it makes copies of everything in that initial, in that load case. So I'm going to now activate this. And I want to change the load. I don't know why this thing won't let me expand there, because I'm going to go into this load here. I'm going to change it. Let's say I want this to be coming at a 45-degree angle this way. I'll make it negative 45 degrees. Say OK. And there's that load case. I'm going to clone load case 1 again. And I'm going to activate load case 3. I'm going to change that load again. I'm going to change it so now it comes at a different angle. Clone it again. Make load case 4. Edit this one. And I'm going to change it so it comes back this way. Get to the right angle here so I can make sure I turn it the right way. And one more load case here. We're going to put a moment on that one. Actually, I just realized that load case 4 there, I got the wrong angle on it. Let me change that super quick. Let's make this negative 45. That looks a little bit better. Load case 5, I'm going to change that load to a moment, or the force to a moment. So if I clear the face, change this to a moment, apply it to this face here, still make it 100 pounds. There we go. All right, so that's all the load cases. Sorry, that took a little bit of a time there. So now I'm going to go to my objectives. So I can minimize mass, I can maximize stiffness, I can do a modal frequency, displacement, or buckling. I'm going to actually just keep with minimize mass. If I go to maximize stiffness, one of the issues here is I have to have a mass target. And if I'm going to have steel versus aluminum, my mass target could be hard to define because, you know, the two different densities are going to be kind of hard. So just from the folks that I've heard from Autodesk, they usually just go with the minimized mass and then they specify a safety factor. We're going to leave that at 2. We'll say OK. So for my manufacturing methods, you can see here I can enable costing. If I enable costing, then it will then let me kind of just run a sample production run there of what I'd theoretically be wanting to do. Unrestricted, again, is that method where it just tries to find the best shape regardless of manufacturing method. Here with additive, I can tell it which build directions I anticipate it wanting to use or are using for this. And each one I select will result in a different outcome. So it would basically use any material that I have that I've defined, that I'll pick in a second, with all the different orientations of additive. So if I have 2 additive materials and 3 build directions, it would come out with 6 different additive manufacturing methods or models for me to pick from. Thinking of this design here, I'm thinking that Z might be an all right direction. X would be okay. I'm going to maybe think, well, Y is probably to be all right too. So I'll leave all those on there. You can see I can tell it what my wall thickness would be. and what my overhang angle would be. Coming down here, by default, it's going to have a 3-axis milling operation. I could change that to 2.5 or 5. And then here, all of the tool directions, what this is for configuration 1, how many setups would I have for this, and what orientation would the tool come in from those setups? So you can see right now it's going to try to come down from the top in a Z minus. I don't think that's a really good idea for the tooling in this case. I'm thinking that the Y plus and Y minus would be a good option, and maybe either the X positive or the X minus. I'm going to say X minus because it's going to come from here towards the back. So it's basically the direction the tool goes, it goes down in the X, which makes it X negative. For this one, I can then say what my tool diameter would be. I think 0.375 is a little bit too big. I'll drop it down to say 1/4. The shoulder length is so it understands how deep it can get when it's trying to do these mills. And then the head diameter, you just basically want to match what you have on your mill. I could add another configuration here if I wanted to try maybe 5-axis. I've done this with 2.5-axis and it doesn't look the best. I'll try 5-axis here. When I go 5-axis, notice I have basically, I don't have to say anything. I don't have to put any kind of setup direction. If I went to 2.5, you can see I can again set up the tool direction. I'll just throw 5-axis on here and I'll kind of mimic some of the other settings I had. I'll make that a little bit smaller tool diameter, make this a little bit smaller here. 2-axis cutting I don't think would be appropriate in this case, and I'm just to save computation time, I want to skip the die casting. But if I go to die casting, just to show you what happens here, it basically tells you, okay, which direction is it going to be pulled out of the mold, draft angles, minimum and maximum wall thicknesses. Just to show you 2-axis cutting, again, what axis is it going to be cutting in, and what's the minimum wall thickness. Say okay there. Material wise, let me get back into materials. There we go. So I can filter it by methods. So when I add a material, I can put it in all methods or a specific one. I'm going to go to my additive. You can see it automatically has a default aluminum one there. I have a couple different libraries down here at the bottom. I'm going to use the additive library and grab one of the Inconels into that one. If I come down to my milling, you can see it's already got an aluminum. Maybe I'll switch this over to the regular library, and maybe I'll grab a stainless steel just for the sake of it. You'll notice that some of these have a little calculator next to them. Those are the ones that are supported by the costing method. If you see a material that doesn't have that, like this stainless steel, it's not going to be able to estimate the cost for it. All right, so I've got a couple for milling. I've got a couple for additive. You know, the more options I pick, the longer it's going to take to calculate, the more outcomes I'm going to have. I'm just trying to keep this somewhat on the simple side. So I'll say close here. I can do a little pre-check. You can see the milling, it kind of thinks the head diameter is a little large. Just for the sake of keeping things simpler, I'm just going to kind of leave that go. I can do a previewer. The previewer is going to try to start showing me a rough shape. There's nothing I can do from that previewer. I can't save it or anything like that. It's just a good idea to run that to see if you've got all your preserves, obstacles, and everything else set up right. I've done this a couple times where I'm like, oh man, that doesn't look right at all. Oh, I forgot to define an obstacle. That's why it's not looking right. But this is looking pretty good. So I'm going to stop the previewer. I can tell it to generate the solutions. And I'm going to tell it to run the study. While that's kind of calculating here, very early on, it took 25 cloud credits to run the study. Autodesk has made a change that it doesn't require that anymore. The only time you would incur a cost doing this is when you look at your outcomes and you say, I like this one, I want to make it into a model. That costs 100 cloud credits. For years and years and years, when you were buying your software, you were getting some included. You might already have some. It's basically a cloud credit is $1, so it basically costs $100 to take one of the outcomes and make it into an actual file that you can work with. Otherwise, it's just going to be kind of an outcome there. From what I've talked from my talks with folks at Autodesk, most customers are taking 2 or 3 files and making them into actual files. It's just a matter of, when you kind of start looking through your results, which ones you want to try to evaluate. So this is going to take a few moments. As things start to happen, it's going to start previewing here. I think what I'm going to do is I'm going to go over here, just like a cooking show. I have one that I did yesterday. I just got to make sure I grab the right one that I did yesterday. This is, I recorded a video of this just in case for some reason I had any technical issues, which I've been prone to have in the past. So if I go to my Explore here, and don't tell me that the study needs to be rerun. Okay, it's going to load here some results. So you can see I actually did a 2.5 axis milling, which makes that thing kind of look a little bit odd. But it started recently to give you what they call recommendations. So if I pick on one of these here, I can kind of preview it, kind of take a look and see what I have. You can see it looks a little bit kind of like something that might have been 3D printed. If I look at the production method here, this is one of the unrestricted ones. Its range to produce would be 55 to 115. It's made out of aluminum. Its safety factor is actually 2. So there's that. If I wanted to make this into an actual CAD file, this is where that create design from outcome would be. If I click on this, you'll see this gets into costing 100 cloud credits. I'm going to finish my outcome view. Just to show you here, over here on the side, if I go to manufacturing method, I can turn off or turn on certain ones. If I want to look at only the 3-axis millings, what do those look like? I can turn those off, let it recalculate that here. That one failed. Let's see. Let's maybe look at an additive one since the 3-axis millings weren't showing too great. So here is one that is from an additive manufacturing. There's a couple different ways you can look at them. You can look at the Explore, the thumbnail view. You can go to Properties view, where it will show the thumbnail and then all the properties below it. A lot of folks like to use the scatter plot, where I can set up 2 different things to look at, minimum safety factor versus mass. And you can see that it's going to show me different outcomes. You can see I've got one here, one there. The green is Inconel. The blue is aluminum. This one here is one of the recommendations. That's why it's got the little thumbs up. All of the other ones kind of show up as dots here. As I turn on some of the other options, I can then zoom in on my table here. If I just kind of draw a little window, I can kind of zoom in. Aluminum 6061 is these orange ones. So there's lots of different ways of sorting and filtering through here. And I'm kind of up, getting close to my hour time limit here. So basically, it's just a matter of, in that Explore, you have all kinds of different filtering methods. Some of these here are ranges that you can kind of drag and say, okay, I want to look at in this range of mass. I want to look in this area of volume or safety factor. I only want to consider anything over 2 or over. And then that will kind of help me filter some of this stuff out. So that's fairly straightforward. Like I showed you before, if I find one that I like, this blue box would let me save that as a file. This one here would create a mesh. So I prefer the blue because it's going to be that real solid model. If you rather have a mesh file, mesh output, you can do that. There's also some methodologies to kind of compare and kind of show, 3 or 4 at the same time. But I really want to kind of get to the end here. of the workflow. I do have some that I did yesterday, and I actually outputted one so you can see what that would look like. So here's one of the ones that I exported out as an actual CAD file. And I actually was still in the simulation environment. Let me back out the design. So there is an actual design history down here. So basically it derives some bodies in, it creates a new one. It does this thing called boundary fill, where it kind of combines and fills in. And then it also, I believe it then combines with that output, or it does a merge with your preserved bodies. This T-spline shape in here, I can actually modify that. If I go in here, I can say edit. You can see I get all these edges here. I don't want to spend too much time on T-spline editing, but a really simplistic version of T-spline editing, if I can get this thing to set up right here for me, is I can come in here, grab a collection of faces. Oops. Grab a collection of faces here. I can then use something called edit form. And then I can kind of basically do like some direct editing to kind of position that where I need that to be. I'm going to just maybe pull these out just a little bit. So I can kind of mold and shape my outcome. What I said earlier is if I go into the simulation environment, let me finish the form here. If I jump into my simulation environment, I already did this already, so it may not throw that message again. But the load cases that I had on that file initially all get brought in. So you can see there's my load cases. That's one of the benefits of going from here into this environment, is it would then have all those load cases. I could run the solution on this and see if it actually solved it. If what I'm trying to say is see if my edits compromise the results at all, or if they improve them, or whatever. So the final stage to all of this is, let's say I've got this thing all ready to go. You're like, okay, Steve, that's great. That's a good file. How do I get this back over to Inventor? Two options. I can export this. So you can see I have export, which would let me export this out as either a step file, or it actually will create an Inventor 2019 file. That's just, they go back far enough to kind of cover you in case you're using different versions. One of the benefits of what I'm using here is I'm using that Fusion team with the desktop connector. So if I go back into my assembly here, again, that desktop connector synchronizes my cloud storage to basically a folder on my C drive, and this Inventor project is looking at that location. So I can come to this caster frame here, and what I did earlier when I realized I forgot to reset this file is I went to Component, Replace, and I should completed caster. Those are the IPTs. I got to change this over to show me all files. So there's this caster 3-axis, which was the manufacturing method that I use, Fusion Design, say open. And because Inventor has AnyCAD, it's going to treat that as a reference, and it's going to place that into my design. Because the orientation axes of them are different, I'll have to correct the constraint. But other than that, it's gonna be a live connection. The beauty of Fusion Team is I'm not doing any exports or imports. So if for some reason I decide I need to make a change, it's not going to be a big deal. I'm going to be able to do that. Everything connected is going to be able to be updated. Let me edit this. Make that a rigid joint. There we go. Let's edit this. I forgot about that flush constraint there. I don't necessarily need. Oops. I could actually have left that as a rotational. I have a flush constraint that makes it stand up in the right location. So there I've gone all the way, took this over to Fusion, built my generative design, got the right output, saved this to a file, then brought it back into here. So I'm right around my 11 o'clock hour, which is what I usually use as my time limit for these. But do you guys have any questions out there? I know I kind of threw a bunch at you. But any questions, feel free to kind of throw those in the chat panel while you guys are kind of maybe getting some thoughts together. A quick poll for you. Now that you've seen this and kind of got an idea, do you think you could actually make use of this? So let me kind of throw a poll here real quick at you. Now that you've seen this, is this a workflow you think you could possibly use? I'll give you another 10 seconds or so to respond here. Just over half of you have voted or responded. All right, so I'm going to close it, share the results. So we've got kind of just over half of you want to see a little bit more. One of the things that I have planned for 2021 is a class on this. So be on the lookout for that. It's going to be Inventor based. I could also teach a Fusion based one if there's anybody out there using solely Fusion, but most of our customers are using Inventor, and that's why I'm going to have sometime next year, I'm going to have a class introduced that is going from Inventor into Fusion, doing your generative design there, and coming back. So it's something we're looking to have added for our new year. I've been working on that class for a couple months now, so hopefully it'll be ready for next year. But any questions about, let me hide those results there. If you have questions, you're like, I'd just rather email you, Steve, feel free to do so. Feel free to give us a call. I'll be around most of the week this week. If you have any questions, or if you want to just have more of a private conversation about generative design or what you might be looking to do with it, I want to, before I sign off completely, I want to thank all of you for taking time today, wherever you might be, whether that be at the office or working from home, and to join me for this. I appreciate you taking the time. We'll have this, I recorded the session so we can then post it later on. So later today or tomorrow, you should see this. If you go back to our website, you should be able to find a recording of this. You can feel free to download and try to watch this again, maybe try to follow along on something of your own or something similar. By all means, if you have any questions, feel free to reach out to us. But I want to thank you all for joining me, and I'll talk to you next time.